Let's do another physics problem. A rock climber is descending at a steady rate of 0.92 meters per second when a piece of gear falls off his climbing harness. After 4.3 seconds, what is the velocity of the gear? All right, so rock climber is descending at a steady rate, so 0.92 meters per second. So that means each second he travels a distance or displacement of 92 meters, 0.92 meters. And while he's doing that, a piece of gear comes loose and falls off. We want to know how fast is it going 0.43 seconds later. All right, let's go ahead and draw a diagram of this. So there's the gear, and it's falling downwards. Now be careful here with the initial velocity. There's a tendency to put 0 there, but that's not what it is. Remember, the climber and the gear are both moving downward at 0.92 meters per second when the gear comes loose and falls off. So the gear actually comes loose and falls off as the gear and the climber are moving downwards. So the initial velocity is actually 0.92 meters per second. And should I make that a positive 0.92 meters per second or a negative? Well, again, I like to make the initial direction of motion positive. So initially, the gear and the climber are moving downwards. So I'm going to make down my positive direction. So that's going to be a positive number. And we're trying to figure out how fast is it going after a certain amount of time. So the time was 4.3 seconds. And remember, there's an additional piece of information that we need to, that we should know that wasn't given. What's accelerating this piece of gear? Gravity on Earth. So we know the acceleration due to gravity on Earth, and it's going to be 9.81 meters per second squared. And then the question becomes, should I make that a positive 9.81 or should I make that a negative? What's the direction of gravity? Well, gravity is trying to pull things or accelerate things downward. Which direction did I make my positive direction? Downward. So this is going to, in this case, the way I set this up, this is going to be a positive number, And again, time is always positive. Time is always positive. All right, so there we go. We're definitely looking for final velocity, so that needs to be in our equation. And then our equation also, has to have the information we have available. So I'm going to choose this equation. Average acceleration equals change in velocity over time. Average acceleration equals final minus initial divided by time. Now remember, we're looking for this, and that means I need everything else in my equation. Do I have the acceleration? I do. Do I have the initial velocity? I do. Do I have the time? I do. All right, so I can use this equation here. What about this equation? Final velocity squared equals initial velocity squared plus 2ax. Right, could I use that? What am I looking for? I'm looking for final velocity. Well, here it is right here. Do I know the initial velocity? I do. Do I know the acceleration? I do. Do I know the displacement? Oh, I don't. So that's why I ruled this one out. Can't use it. What about this one? Change in displacement equals the initial velocity times the time plus 1/2 at squared. Well, I'm looking for, doesn't even have final velocity in it. That was a no-brainer. What about this one? Average velocity equals displacement over time. Initial plus final divided by 2 equals displacement over time. All I did was expand that a little bit. I'm looking for the final velocity. Do I know my initial? Oh, I do. That's nice. Do I know the time? Oh, I do. That's nice. I don't know the displacement. Don't know that. So again, I got to rule this out. I got two unknowns. can't solve. But this is the equation that does the trick. This is what I'm looking for, that's my unknown, and I know all the other information. It's just a process of elimination, that's all it is. Pick an equation that has what you're looking for in it, and then make sure you have all the other information available. If none of the equations have all the other information available, then what you need to do is find an equation to solve for a new piece of information, which then you can put into the equation. All right, let's go ahead and solve this. So, 9.81 meters per second squared. Final velocity, that's what I'm looking for. Initial velocity, 0.92 meters per second, and the time is 4.3 seconds. Final velocity, all right? I'm gonna multiply these two numbers together, and then I'm gonna add that. So my final velocity is 43.103, 43.103. And for the most part, I like to write down the unrounded off number, because whenever there's a part B, you never know if you're gonna need it. Especially in my calculator, I tend to save that unrounded off answer, because usually it's longer than that. Let's go ahead and round this. Final velocity, I got 2, I got 3, I got 2, so I'll round that off to 2 significant digits. And that's gonna be my final answer. So 43 meters per second, that's as certain as I can be about this. Part B, how far below the climber is the gear? So this one's a little bit of a tricky one. How far below the climber is the gear? So you gotta be careful with part B. A lot of people just wanna say, okay, I need to find the displacement from here to here. And that would be incorrect, because the question is asking us not how far below when it was initially dropped, but how far below the climber is it? Now remember, during the time at which this piece of gear is falling, the climber is still steadily descending. So that's the climber. And then the gear obviously falls from here to here during that 4.3 seconds. And this is where the climber goes during that 4.3 seconds. This is where the gear goes during that 4.3 seconds. Remember, the climber's not accelerating. His acceleration is 0. He's maintaining a constant velocity as he descends during that 4.3 seconds. And the reason our gear is so far down here is because the gear is accelerating at a rate of 9.81 meters per second squared. So this is going to be the displacement of the gear. So what I really want to find is I want to find what? The distance or the difference between the two, right? If I take this minus that, that will give me, because this is where the climber is right there, that's where the gear is right there, and that's what I want. That's the displacement that I want. So this is what I'm actually trying to solve for. All right, so we're gonna have to find this, and we're gonna have to find that, and then we're gonna have to subtract. So let's see, I'm gonna put climber here. And I spelled that wrong, climber. And then I'm gonna put gear over here, just to keep things straight. All right, let's deal with the climber first. He's descending at a nice constant velocity. And we know what that is. So I'm gonna go ahead and choose this equation. Average velocity equals displacement over time. I know the average velocity, 0.92 meters per second, equals the displacement, there it is. That's what I'm looking for. And the time the time the climber is descending and the time the gear falls is, they're both going to be 4.3 seconds. So we do our multiplication and we end up with 3.956. 3.956 meters. So that's how far the climber descends during that 4.3 seconds. I'm going to underline that just, so I can find it easily again. Now let's go ahead and deal with the gear. I can't use the same equation with the gear because he's not really moving at an average velocity. The gear's not moving with an average velocity, displacement over time. Actually, I probably could use it. Let's see. Average velocity equals displacement over time. Velocity initial plus velocity final divided by 2 equals displacement over time. Do I know the initial velocity of the gear? I do. It was 0.92 meters per second. Do I know the final velocity of the gear? I actually do. I had found that in part A. This is my unrounded off number. I could actually do that. And then the time is 4.3 seconds. I could find the displacement from that. Now, when I did it, I actually used this equation here. Final velocity squared equals the initial velocity squared plus 2ax. Just another way. Oftentimes there's more than one way you can do things. And do I know the final velocity of the gear? I do right there. Do I know the initial velocity of the gear? I do. Do I know the acceleration of the gear? Yeah, 9.81. I can find that displacement. So it doesn't matter which equation you use. If you use it properly, you're going to get the same answer. I'm going to go ahead and I'm going to use this one here because that's the one I used in my notes. So for final velocity, I'm going to substitute in my unrounded off number, 43.103 meters per second. Don't forget to square that, equals 0. Actually not 0, 0.92. 0.92 meters per second. Again, don't forget to square that. Plus 2, 9.81 meters per second squared. And then I'm looking for my displacement. So I'm going to square both of these. I'm going to take this and subtract it from that, divide by 2, and divide by 9.81. And when I do that, I am going to end up with 94.649. 94.649 meters. And then I'm going to take, I'll underline that, there we go. So now I'm going to take these two unrounded off numbers and I'm going to subtract them. I want to take the bigger number minus the smaller number, and that's going to give me what I'm looking for. All right, so it's going to be this minus that. You should show that. So what I would do is I would write displacement gear minus displacement climber equals displacement, that I'm looking for. Substitute in the numbers, and when you do that, you're going to end up in, I'm going to also round off to 2 significant digits. When you do that, you're going to get 90.693, 90.693 meters. And then I'll round off to 2 significant digits because of my time, because of my initial velocity there. And that'll be 91 meters. That's going to be my final answer. So, with as much certainty as I can have, the gear is 91 meters below where the climber is. All right, so that's another problem.